Hi, and welcome to Module 12 of Lecture 1. Here we're going to talk about levels of measurement, which are a little bit nuts and boltsy in the sense that we're going to be discussing characterizations of various types of data you might gather. The reason we're doing this, even though it's not as weighty as the previous modules topics, is that the type of data you end up gathering is going to influence how you can analyze the data. So it's good to know up front what kind of data they are. So with that in mind, data tend to fall into two different types, discrete or continuous. And data here are either discrete or continuous, and not both. Discrete data are data that are not continuous, right? So that they exist like number of children, you can count them, right? They're countable. Continuous data are continuous, so there's no spacing between them. You can't count them. There's always something small. There's always something in between any 2 points that you might look at. So age and income, you can always go between any 2 points on that scale. These two broad categories lead to three different levels of measurement that are important in our analysis. And these levels of measurement capture the qualities of the values assigned to the variables. At the least specific, in some senses, is the nominal. It's a nominal variable. A nominal variable is measured by categorically. It comprises categories only. And these categories can't be ranked. We can't order the categories. They're things like east, west, north, and south. There's no natural ordering of those things. They're just cardinal directions on a map. So a variable that consisted of, a value east, west, north, or south would be a nominal variable. The actual categories can't be ranked. Or if the variable were, to whom you voted for whom you voted, it'll also be nominal. There's no necessary natural ranking of individuals, and a vote for a particular candidate is a category, right? Voting for the Republican or the Democrat or the Libertarian or the Green Party or whatever. These are categories of votes, and there's no natural ranking among them. Ordinal variables are also categorical, but they can be ranked. The difference between an ordinal variable and a number is that we can't specify what the distance between the categories means. So, for instance, low, medium, and high. A variable that took values of low, medium, and high would be an ordinal variable, because you can rank them from low to medium to high, but the actual difference between the categories is unknown. How much more high is than medium as compared to medium than low is just undefined. That's an ordinal variable. Finally, interval-ratio variables are numbers. They're just everyday numbers in which the distance between the values has the same value across all values, right? So the difference between 1 and 2 is the same as the difference between 2 and 3, and so on. These are interval-ratio values, and they're numbers. In general, all three of these require slightly different analysis techniques that we'll discuss over the course of the rest of this course. Okay, so starting from nominal, I said a nominal variable is discrete. The categories of a nominal variable cannot be ranked or operated on mathematically. We can't add east plus west to get something else. It's a category. It's a characteristic. Categories in a nominal variable must be mutually exclusive and collectively exhaustive. Mutually exclusive means they can't overlap. You can't have two categories in a nominal variable that you can fall into both of. That's not a well-defined variable. Collectively exhaustive means when you add them all together, you get the entire space of possible things you can be. Because for most of these things, there could be lots of things you could be. Usually the last category is an other, or a not presently mentioned elsewhere type of category. In that way, you get collective exhaustivity. Examples for this might be gender, location, political party, ID. All these things are categorical nominal variables. Often what we do to deal with these kind of variables is create dummy variables that take values of either 1 or 0 based on membership in that category. Doing so allows us to turn a category into a number. Right? So if we have, say, north, south, east, and west as location categories, we could create three different dummy variables, and 0, 1 for north, and 0, 1 for south, and 0, 1 for east, and then west is left off for reasons we'll discuss later. But if you have all zeros for north, south, and east, then by default it must be west. That's why it's left off. So that's a way of turning a single categorical nominal variable with many categories into a series of dummy variables. That helps us analyze data that's nominal. These numbers, though, these zeros and ones that you attach to the categories, mean nothing beyond identifying what category you're in. Having a 1 instead of a 0 does not mean you're better in some east category. It just means 1 means east. A more complicated example might be religion. Here you might have, Christian, Muslim, Jewish, other, atheist. And here's 5 different categories. That's not unique somehow. You could make 300 categories of religion if you wanted to. It's just whatever is needed for your particular analysis. Plus, if you have 300 categories, you need a lot of data to have most of it make sense. So here we could put it into 5 categories with 4 dummy variables, with the last one left off for reference. You never want to include all 5 as dummy variables. So you have a variable for Christian or not, for Muslim or not, for Jewish or not, or another religion or not, with atheist left off as a reference category. Okay. Ordinal is very similar to nominal. It's discrete, it's categorical. The difference is the categories can be ranked in some order. The distance between those categories, as we said, is undefined. I don't know what low to medium means in any kind of mathematical sense, but there is a difference, and low and medium is more in that variable's ordering than low is. Categories, again, must be mutually exclusive and collectively exhaustive. Some examples might be highest school completed, none, little, often, or always, right? So highest school completed might be like, did you get through elementary or secondary school or some college or finished college or postgraduate education, right? You might have these categories. That's an ordinal variable. The difference between some college and finished college is not defined well mathematically, but along the axis of education, right, schooling, right, going from some college to finished college increases on that axis. So there's a natural order to the axis. Other times you see this a lot are these none, little, often, or always type of survey questions you might have seen before. Right? Obviously, none is in the low end of that scale, and always is in the high end of that scale. But the difference between little and often is undefined. Okay. And finally, interval ratio. These are slightly different, but they're both numbers. They can be discrete numbers or continuous numbers. The important point is they have a constant distance between values. 0 to 1 always the same as 1 to 2. It's a constant difference. So it has a meaning. So not only do the values have meaning, but the distance between them has meaning as well. The difference between interval and ratio is that interval variables have an arbitrary 0 point, whereas ratio variables have a meaningful 0 point. Again, any categories you have numbers have to be mutually exclusive and exhaustive. Numbers naturally do that, so it's reasonably safe. But years, income, temperature, these are all examples of interval ratio variables. Okay, so for the next few, I'm going to go through some examples of these things. Level of measurement for different cases. What I'd like you to do is I'm going to show this on the screen, and then I'm not going to pause, but you should pause me. Try to figure out if you can figure out the answer by yourself, and then listen to my explanation of the answer afterward. Okay, here's the first one. Family income, which measures respondents' reported family income. That was for the pause. So here we have 4 different categories, which is already a hint, right? Less than 25,000, 25 to 50, 50 to 75, or more than 75. Even though there are numbers involved in this is not interval ratio because we've broken them down to categories. In this case, it's an ordinal variable because there's an ordering for income from lowest, which is less than 25,000, to highest, which is more than 75,000. So as an ordering, the categories are in fact exhaustive and mutually exclusive and collectively exhaustive. They cover all possible incomes, and they don't overlap at all. Note you have over here greater than 75. This shouldn't be 50 to 50. It should be slightly less than 50, so they don't overlap at all. So there are 4 categories in this case. So it's an ordinal variable. It's not nominal because the order matters, and it's not interval ratio because the distance isn't constant, right? So the difference between less than 25 and 25 to 50 is undefined. It depends on where you are within the ranges. So we can't say that they're numeric. We can say it's interval or ratio. You might ask, why would you take a variable in which you have data on a number and report it like this? Well, A, sometimes people are more willing to answer questions about general income categories than explicit incomes they have. But B, your theory might not be that fine-grained about exactly what income means, and all you might really be interested in is our broad swaths of income, in which case you don't really need detailed income information. Okay. How about this one? Who did you vote for in 1996? Pause. In this case, you have three possibilities: Clinton, Dole, and Perot. And this is a nominal variable because there are three categories. You can't order them in any kind of natural mathematical way. And that's it. So that's a nominal variable. Okay. This one is a question. Do you favor making a law making English the official language of the U.S., meaning government businesses would be conducted in English only, or do you oppose such a law? So again, there's two categories, and pause. Okay, so here's a little tricky. Many people say at first nominal because there are two categories, right? And favor and oppose don't seem that they have a natural ordering. But in this case, the answer is actually ordinal. And the reason is the question is about favoring a law. So the response is more or less favoring that law. So oppose in this case is on the low end of favoring, and favor is on the high end of favoring. So there's a natural ordering of favoring in this question. So oppose is less, favor is more, and it's an ordinal variable. This kind of thing often happens with yes/no questions, right? And you can ask questions in different ways, right? So you can ask someone, you can ask someone a question about, do you live in the West Coast? Yes or no, right? In that case, that might be an ordinal response because yes is more living in the West Coast than no is. On the other hand, if you ask them, where do you live, north, south, east, and west, it's definitely nominal. So the way you ask questions can alter the level of measurement in some fashion. In this case, it's an ordinal variable because oppose is less favoring than favor is. And it might make more sense to you if you think about expanding these categories to add oppose fully, slightly oppose, neutral, slightly favor, and favor. Then it's 5 categories, and it might seem more clear that it's an ordinal variable. Okay, and the final one is unemployment rate in 2001, and what you see 2000. And what you see is these are all numbers, so this will be interval ratio. Right, these are giving you actual unemployment rates. The numbers have meaning. You can compare them across different numbers in a clear mathematical way. So it's a interval ratio variable. Okay. So in general, why are we doing this? You may need to decide at what level of measurement you want to measure your variable. And this can have consequences both for analysis statistically, but also for theory, right? So if you're measuring education, you have a choice. Do you want to actually count years in school, in which case it's a ratio variable? Right? 0 means something. It means you have no years of schooling, and then each additional year is another year. Or does your theory not specify that much detail about education? Do you not think there's much difference between 10th and 11th grade? In reality, all you really care about is, did they finish high school? Did they finish college? Things like that. Right? In which case, you might want to measure right off the bat education as an ordinal variable and just look at the highest level of schooling completed. As always, the decisions are based on theory, right? As a basic rule of thumb, don't toss information that you have, so if you had data on every year of schooling, don't throw it away unless there's a strong theoretical reason to do so. So if your theory is about people above and below the drinking age, you don't really need ages exactly. You might just need above and below the drinking age. But if your theory does require age more generally, don't toss age and put it into categories just because you can. Okay. That's it for this one. Thank you very much.